Hello, today we're going to start section 3.3 or 2.3, adding and subtracting rationals. So with our rational fractions, just like how you would add and subtract numerical fractions, it's going to be the same process, but with polynomials. So just like when you would add fractions back in the day, you need to have a common denominator before you can add, and once you have that common denominator, you would just add the numerators and leave that denominator the same. We're going to be doing the same type of process, except we're just going to be seeing polynomials inside of our fractions. So if we look at this first expression, we have like denominators already. They're the same denominator. So that's the easy type. So when that happens, you just have to keep the same denominator. So we're just going to keep the 3a minus 4. Then we're going to go ahead and add the two numerators, so 2a plus 3a. And then since 2a and 3a are like terms as well, we can go ahead and combine those to be 5a over 3a minus 4. And then once you have your fraction added or subtracted, you do want to reduce it if possible. But remember, whenever you have like a binomial or a trinomial, it's considered a group. It's all or nothing when you cancel it. So I can't start canceling a's here because I would have to include the 4. So we're actually as simplified as we can. We can't cancel those a's. We're just stuck the way it is. Let's do one more of these easy ones where we already have a common denominator. So on this one, again, we have the same denominator, 2c plus 7, 2c plus 7. So your answer, you're going to keep the 2c plus 7. And then you're going to add the numerators. So I would have 5c plus c minus 28. But then these are like terms, so we can go ahead and add those c's together to get 6c minus 28 over 2c plus 7. And then here we could try and reduce. We could take out a number that goes into the 6 and the 28, which would be 2. If I take that 2 out, though, I don't think it's going to help us because we end up getting 3c minus 14 over 2c plus 7. And again, I can't cancel these 2's because this is a group and it has to stay stuck together. So actually simplifying that one doesn't really help. I would just keep it in this format. Okay, let's try a subtracting one. Subtracting is going to be the same process, but again, you just have to be careful with your signs. I'm actually going to skip this one and do this one because it's going to be a little bit trickier. We have those common denominators, which is good. We keep that 10n minus 4. But then in the top, we're going to take the first numerator, 9n minus 3, and we are subtracting this entire group. So remember, when you're subtracting a binomial, you need to distribute that negative into both parts, which essentially is going to switch the signs. So I'm subtracting the 3n, but then I'm also subtracting the positive 5, so this is going to turn to a minus 5. So just be careful with your signs when you're doing the subtracting. That's usually the mistake I see made on these. But then we want to try and combine our like terms, so I can combine my n's here. 9n minus 3n is going to be 6n, and then negative 3 minus 5 is going to be negative 8, and then we keep the 10n minus 4. And then on this one, I do think we're going to be able to cancel out some stuff if we reduce it. So let's take a 2 out of each. That leaves me with 3n minus 4 on the top. And if I could take a 2 out of the bottom, I'm left with 5n minus 2. And so those 2's can cancel. So the reduced form would be the 3n minus 4 over 5n minus 2. And again, a common mistake I would see is students would try to cancel or reduce the 4 over 2 or cancel the n's, but with this group it has to match exactly. So it's all or nothing. So since those binomials don't match exactly, we can't cancel anymore. And that would be your answer. Okay. Let's get to ones that have different denominators. I'm actually going to skip that one as well just for sake of time. And let's do some that have different denominators because these are going to be the ones that are trickier. So when you add or subtract rationals that have different denominators, we need to get a common denominator. And the way we're going to do that is by using the LCD, or the least common denominator. You would do this process with number fractions as well. We're just going to have to find the LCD with variables now. So remember, the least common denominator means you're finding the smallest thing that both denominators can go into. So if I look at this fraction, I have a 7y to the 4th and a 3y squared. I want some fraction that both numbers can go into. So I usually start with just the numbers first. If I think of 7 and 3, I want to think of a number that both 7 and 3 can go into. So for 7 and 3, the smallest number they both go into is 21. And then when it comes to the variables, notice this one is a y to the 4th, and this one is a y squared. 2 y's can go into 4 y's, so I don't actually need to change or go bigger than my biggest amount of variables. So when it comes to your variables, just find your biggest exponent, which in this case is a 4, and we're going to use that y to the power of 4 as our variable, since y squared can go into y to the 4th, and y to the 4th can also go into itself. So we don't need to do anything bigger. We don't need to do like y to the 5th or y to the 6th. So just find your biggest exponent, and that's going to be the variable on it. So this is our LCD. So our process now is we're going to try and turn each fraction into this LCD. So for 7y to the 4th, I need to think, what do I need to times it by in order to get 21y to the 4th? Well, to get 7 to turn into 21, I need to times it by 3, and then y to the 4th is already y to the 4th, so I don't need to times it by any more y's. But whenever we multiply a fraction, whatever I times to the bottom, I also need to times to the top. So if I times my denominator, I also need to times my numerator in order to keep it fair. So 3 times 3 is 9. So my new fraction that's going to replace this one is 9 over 21y to the 4th. And then let's do the same thing for the second fraction, 2 over 3y squared. I need to think, what do I times it by in order to get a denominator of 21y to the 4th? Well, to get 3 to turn to a 21, I need to times it by 7. And then y squared to turn into a y to the 4th, I need to times it by another y squared, so that when I have these exponents, remember we add them when multiplying, so 2 plus 2 is 4. But just like on the previous fraction, whatever we times the denominator by, I need to times the numerator by. So on the numerator, we're going to get 2 times 7, which is 14, and then times y squared. So we have 14y squared. So we're just going to rewrite the original problem using these two new fractions so that we have a common denominator. So we're going to have 9 over 21y to the 4th plus 14y squared over 21y to the 4th. And so our answer, we just keep the common denominator, 21y to the 4th, and then we're going to add those numerators, 9 plus 14y squared. But then on this numerator, 9 and 14y squared are not like terms, so we can't actually add them together, so we're just done. And I don't think there is anything we can factor out. So 9, 14, 21, we can't factor a number out, so we're done reducing as well. So that is adding with different denominators. Let's try another one. We have 5x to the 8 and 3x to the 6. So first we want to identify that LCD. I again start with the numbers. So I want to think what can go in, or what number can 5 and 3 both go into. And the smallest number they both go into is 15. And then I have an x to the 8 and an x to the 6. I'm going to take the bigger of the two, and that's going to be my variable. So 15x to the 8 is my LCD. So now I'm going to take each fraction, and I'm going to figure out what I need to times it by in order to get my LCD in the denominator. So I'm just kind of filling in the blank here. So what do I need to times this denominator by in order to get 15x to the 8? Well, for 5 to turn into a 15, I need to times it by 3. And then we already have the correct amount of x's, so we don't need to change the x's at all. But that means I need to times the top by 3. So 6 times 3 is 18. So my new fraction will be 18 over 15x to the 8. So then on our second fraction, we have 4 over 3x to the 6. So I'm thinking, what do I need to times 3x to the 6 by in order to get 15x to the 8? Well, 3 times 5 will give me the 15. But then right now I still only have 6 x's. I need to have 8 x's. So I need to times it by an additional x squared. So that when I times those two together, 3 times 5 is 15, and x to the 6 times x squared is x to the 8. And then we times the numerator by the same amount. So 4 times 5x squared will be 20x squared. So here's our two new fractions. We're just going to rewrite that problem. So I'm going to take the 18. Just make sure you guys can see what I'm doing. And take the 18 over 15x to the 8. I'm going to add to it the 20x squared over 15x to the 8. So we keep that same common denominator on the bottom. And then on the top we get 18 plus 20x squared. So just like the last problem, the 18 and the 20x squared are not common, or not like terms, so we can't add those together. So since we can't add the 18 and the 20x squared, we just leave it. And then it looks like we can't reduce anything as well. There's not a common number or variable between all three terms, so we are done. So that's what you do on ones that have just one term on the bottom. Notice that both of these problems were just monomials on the bottom. But what happens if we have like a binomial on the bottom? So on number 6, we have an m plus 2 and an m minus 7. If I think about m plus 2, there's nothing I can times this binomial by that turns it into m minus 7, and vice versa. So these types of problems, their LCD is actually just going to be this binomial times this binomial. So it's going to be m plus 2 times m minus 7. And if you wanted to, you could FOIL it and turn it into a trinomial, but I actually think it's easier just to leave it in that factored form, and I'll show you why in a second. So in a way, these are almost easier because all you're going to do is you're going to take each of these fractions and you're going to times it by whatever piece it's missing from the LCD. So this one has the m plus 2, so I need to times it by the m minus 7 on both the top and the bottom of the fraction. So that my LCD, again, I'm just going to leave it in factored form. I'm not going to worry about multiplying it through right now. It's just going to be the m plus 2 times m minus 7. And then on the top, I'm going to distribute. So I'm going to get 9 times m. And then 9 times negative 7, which is a negative 63. Okay. And then we're just going to repeat the process for the second fraction. So 8 over m minus 7. So this time it has the m minus 7. So I need to times it by the part it doesn't have, which is the m plus 2 on the bottom and m plus 2 on the top. So again, on the denominator, we're just going to get that lovely LCD. Then on the numerator, let's distribute that. So I have 8m plus 16. And now we have the common denominator we need. So we're just going to rewrite this problem using these two fractions. So I have 9m minus 63 over m plus 2, m minus 7. And then we're adding to it the second fraction, 8m plus 16 over our LCD. And then with our answer, again, we just keep that common denominator. So we're going to have the m plus 2, m minus 7, and then now we're going to add our numerators. So I have 9m plus 8m, which is 17 m's, and then negative 63 plus 16 is going to be 47. And then here you can sometimes just actually leave that denominator in the factored form, or you can go ahead and distribute it and do your foiling. which we'll just keep the 17m minus 47 on the top. But then here we get m squared, and then m times negative 7 is negative 7m, but then plus a 2m is a negative 5m, and then 2 times negative 7 is negative 14. So this would be if it's all multiplied out. So I usually just wait to do that until the end. You could do it at the beginning if you want, but sometimes I think it's easier just to do it at the end. And that is how you do it when you have binomials on the bottom versus a monomial, so one term versus two terms. Okay, let's do a subtraction one so that we can practice making sure we get our signs correct. So here we have c over 3c minus 1, and then we're subtracting 4 over c minus 2. So again, the LCD on these is almost easier because you're just going to take this bottom and times it by that bottom. You have 3c minus 1 times c minus 2. And then whatever piece you're missing from this fraction, you're going to times it with the other piece. So c over 3c minus 1. My baby's just waking up. You can maybe hear her crying in the background. So since I have the 3c minus 1, I'm going to times it by the c minus 2 on the top and the bottom. So I'm going to distribute the c through on the top, so I get c times c is c squared, and c times negative 2 is negative 2c. But then on the bottom, I'm just going to keep it in the factored form. I'm just going to smush those two together for now. And then on the second fraction, we have the 4 over c minus 2. We're going to times it by the piece that it's missing, which is the 3c minus 1. On the top and the bottom. So distribute that 4 through. So that on the numerator we have 4 times 3c is 12c, and 4 times negative 1 is negative 4. And then on the bottom we just get that lovely LCD. And now we're ready to subtract. So rewriting our problem, we're going to take the c squared minus 2c over our LCD. And subtract the second fraction, 12c minus 4, over our LCD. And then again, whenever you're subtracting, I've got like light shining on that. When there's a binomial or a trinomial on the top, you need to make sure you're distributing that negative through. So watch those signs here. So that in the numerator, I have c squared, then I have negative 2c subtract 12c, so 2c minus negative 2c minus 12c is going to be a negative 14c. Then we're also subtracting a negative 4. So when I subtract that negative, it's going to turn to a positive 4. So careful with that negative that you're getting your signs correct. And then on the bottom, here's when you can start actually foiling your LCD. So I'm going to do 3c times c, which is 3c squared, and then 3c times negative 2, which is a negative 6c, and then I'm going to have negative 1 times c, which is a negative c, so those two together are going to be a negative 7c, and then negative 1 times negative 2 is going to turn to a positive 2, and so that would be everything expanded, an expanded form. And then if you could, you would want to just cancel and reduce, but there's not going to be anything on this one that cancels, I think. Nope. Okay. Let's just do one more and then we're going to be done. Let's do number 8. Notice on this one we have one term and two terms. We haven't seen one like that. They've all been either one term or all been two terms. So when you have one term on the bottom of one and two terms on the bottom of the other, again, there's nothing we can times t squared by to turn it into a t plus 1, or vice versa. I can't times t plus 1 by anything and turn it into just a t squared. So the LCD in this scenario is going to be the same process where you're just going to times the two together. So our LCD is going to be t squared times t plus 1. So I'm going to take the first fraction, we're going to rewrite it by timesing it by the missing piece it doesn't have, which is t plus 1 on the bottom and on the top. So on the top, I need to make sure to distribute that 5 through so that I have 5t plus 5. And on the bottom, I'm just going to sandwich them together. And then our second fraction, we have that 4 over t plus 1. I'm going to times it by the missing t squared on the top and bottom, so that I get 4 times t squared on the top, and then we have the LCD on the bottom that we need. So this one was a subtraction one, so make sure you're getting your signs right. We're going to take that first fraction, 5t plus 5, over the LCD, and we're subtracting the second fraction, 4t squared, over the LCD. So we only have one term here, so we don't need to worry too much about the signs, but we're going to subtract those so that the LCD is still on the bottom. And again, if you wanted, you could start distributing that through, and you would get t squared times t is t cubed, and t squared times 1 is t squared. So if you want it in expanded form on the bottom, you can do that. But then on the numerator, if we look at all 3 of these terms, none of them are like terms. We have a t, we have a constant, and we have a t squared. So we actually can't combine any of them. I do still like to write these when possible in descending order. So that means we take the highest degree first. So I'm going to actually take this negative 4t squared. Make sure you bring that negative with since we were subtracting it. And that's going to go in the front. And then the 5t plus 5 is going to go after that. Just because, again, I like to go descending, where I'm going my t squared, then my t, then my constant. And that would be the technical true format of writing your answer out. And then that would be your answer. So when you come across ones where it's a 1-term monomial and a 2-term binomial, again, your LCD is just going to be those two smushed together. So, and then I do just want to add one example of my own really quick that isn't covered in these notes, but will show up on your homework. And if you look at these denominators, we have 2 binomials here, but if you look at this x squared minus 49, this is one of those difference of squares that we learned in Unit 1. So if we look at x squared minus 49, remember, if a difference of squares, it will factor to be the square root of each of the squares. So the square root of x squared is x, if I take the square root of that, and the square root of 49 is 7. But one is a plus and one is a minus. So if I can write x squared minus 49 as x plus 7 and x minus 7, well, my other denominator already is an x minus 7. So my LCD on this one is going to be a little bit different because we have this relationship here with this difference of squares. So because x minus 7 is a part of the factored form of x squared minus 49, we can just actually use this factored format as our LCD, x plus 7 and x minus 7, because x squared minus 49 is the same as this, right? They're just, one's expanded form and one is factored form, and the x minus 7 can go into this, it's just missing the x plus 7 part. So ones like this are actually easier because I don't need to change this denominator at all because it already matches my LCD. They're just written in different formats. So the only one I need to actually change is the first fraction, the 5 over x minus 7. It has the x minus 7 already. I just need to times it by the x plus 7 on the top and the bottom. And so let's distribute that 5 through the numerator, and I get 5x plus 35. And then our denominator is just going to be the x plus 7, x minus 7. So our original problem, I can replace this fraction with this guy. We have 5x plus 35. And you can write your LCD in this format, the factored form, or if you want to write it in this expanded form, you can as well, because remember, this equals x squared minus 49. These are the same thing. So I'm actually going to write it as x squared minus 49, just to make it look a little bit prettier. And then it matches the x minus 77 over x squared minus 49. So we have that common denominator now. So we actually didn't even need to change the second fraction at all. We just needed to change the first one to get it to have that x squared minus 49. So it's kind of nice actually. So when we add those, let's add those numerators. 5x plus x is 6x. And then 35 minus 77 is negative 42. And then we'll just keep that bottom as x squared minus 49. And then if you could try and reduce it, but there's nothing that goes into all four terms, and these groups don't cancel perfectly, so we're just done. And so that is how you would do that. So keep an eye out for ones like this that might have that difference of squares in it. They're actually easier than the other ones. So you might see that happen where you have that difference of squares format. So just wanted to say that. Then as always, email me if you guys need any help with this section. I'm happy to help, or set up a Zoom call. I am here to help you. Hope you guys have a good day. See you later. Bye.